MS Ramaiah University of Applied Sciences.
Hi students, let us discuss the system engineering approach used in Electronic Systems Modeling Laboratory. Aim of the laboratory. This course imparts the knowledge to model, design and develop electronic systems. Students are trained to identify the system and subsystem blocks of a desired electronic system. Students are taught and trained to apply the system engineering steps involved in designing, modeling and simulating and prototyping electronic systems. After undergoing this course, students will be able to explain the engineering design process, apply the structured approach to identify the system and subsystem blocks in a given electronic system, model, simulate and implement a given electronic system, interpret, compare with standard results and draw conclusions, write laboratory report as per the prescribed format. Definition of a system. A system is a set of interrelated components which interact with one another in an organized fashion towards a common purpose. System components may be quite diverse: persons and organizations, software and data, equipment and hardware, facilities and materials, services and techniques. A system is, simply stated, a system is an integrated composite of people, products, and processes that provide a capability to satisfy a stated need or objective. System engineering is an interdisciplinary engineering management process that evolves and verifies an integrated, life cycle balanced set of system solutions that satisfy customer needs. System engineering management is accomplished by integrating three major activities: development phasing that controls the design process and provides baselines that coordinate design efforts, a systems engineering approach that provides a structure for solving design problems and tracking requirements flow through the design effort, and life cycle integration that involves customers in the design process and ensures that the system developed is viable throughout its life. The systems engineering process is the heart of systems engineering management. Its purpose is to provide a structured but flexible process that transforms requirements into specifications, architectures, and configuration baselines. The discipline of this process provides the control and traceability to develop solutions that meet customer needs. The systems engineering process may be repeated one or more times during any phase of the development process. System design hierarchy. Majority of systems are developed by an integrated acquisition process. System to subsystems, to components, to subcomponents, to parts. In systems, possess the properties of engineered system. Perform a significant useful service with only the aid of human operators and standard infrastructure. In subsystem, first subordinate level in system hierarchy, major portion of system performing closely related subset of overall system functions, cannot perform without the companion subsystem. In component, commonly used to refer to lower level entities, sometimes can be referred to as middle of system level. In subcomponents, level below the component building blocks, perform elementary functions and are composed of parts. In parts, lowest level entity perform no significant function except in combination with other parts. Commercially available in standard sizes and types. System engineering phases. Needs analysis phase. Define and validate the need for a new system. Demonstrate its feasibility and define system operational requirement. Concept exploration phase. Explore feasible concepts. Define functional performance requirements. Concept definition phase. Examine alternative concepts. Select preferred concept on the basis of performance, cost, schedule, and risk. Define system functional specifications. Advanced development phase. Identify areas of risk. Reduce risks through analysis, development, and test. Define system development specification. Engineering design phase. Perform preliminary and final design. Build and test hardware and software components. Integration and evaluation phase. Integrate components into production prototype. Evaluate prototype system and rectifies deviations. Flow of system engineering process. Requirements are the primary focus in the systems engineering process because the process's primary purpose is to transform the requirements into designs. System design flow starts from requirements definition to system design to subsystem development to system integration to system installation to system evolution to system decommissioning. Work breakdown structure. WBS is a systematic organization of project tasks. Ensures all the essential tasks are properly defined, assigned, scheduled, and controlled. WBS is also called as project or system breakdown structure. Defines all the project tasks to be accomplished in hierarchical structure. WBS formulation begins in concept definition phase to serve as point of reference for concept trade-off studies. Fully articulated to serve as basis for system life cycle. This slide shows the structure of the work breakdown of the system. Implications of the system hierarchy. One man's subsystem is another man's system likewise. These two people have a common interface, but not necessarily a common understanding or purpose. They may have very different perspectives and priorities. Interfaces are essential elements in systems engineering likewise. Interfaces between the subsystems within a system. Interfaces between the system and its environment. This forms a good part of the requirement specification.
At MSR UAS, we spark your imagination unlike any other.